Доброе утро. Надеюсь, что мы всех разбудили этим
Hope we've managed to wake everybody up with this lively video. I don't think there was much that was unfamiliar for you. I'm sure that most of you have attended ICANN meetings. Please raise your hands if you have. Great. Good morning, everyone. Thank you very much for coming to the third Eastern European DNS Forum. This is the first time it's happening in Moscow. This is actually the first ICANN event in Russia. There are other things that have happened here, but not ICANN. And so this is the first time for ICANN to interact with the local community, Russian community, and regional community here in Moscow. And I hope that we will have a good dialogue here. You know, this is a two-day event. Today is a technical day. We'll have technical presentations. And tomorrow we will have discussions on policy development. So right now we will have an informal opening. Statements by the two organizers and organizations that were interested in seeing you all here with us and to discuss issues that are of concern for us. It's very nice to be hosted here by the Coordination Center, the RU.RF Coordination Center. It's one of the strongest ones in the region. So I will yield the floor to my colleague, Andrei Vorobyov. Thank you very much, Alexander. Welcome on behalf of .ru.rf Coordination Center. I will say that this is a very nice opportunity to welcome you to Moscow. This is not the first time we have an international event here. We, of course, had the World Cup. We have the IGF meeting here in June, and I think it was the first time for me we had a high-level meeting with the president of ICANN, Yoran Marby. I think it was, I'm being told it was in May. Anyway, they were very lucky with the weather. Well, I'm not sure about, well, this is not the summer that when Moscow looks really nice, but at least you're seeing a true Russian winter. This is not Siberian winter, but you can still tell everyone that you've seen the real Russian winter. And moving on to serious topics, today this is a technical day. So this is, I see that people aren't wearing suits and ties. I did the same thing. It's tomorrow that we'll need to wear them because we will have some government representatives. Today we'll discuss DNS evolution. We have some interesting presentations, and so I hope that the cold that you can feel outside will be compensated by the high temperature in the room. I see some representatives here that I know will help us raise the temperature in the room from past experience. Anyway, have a successful meeting. Welcome to Moscow yet again, and we will be here for 2 days. Thank you very much. Thank you. We will welcome the first presenter on the floor, in somebody who is well known in Moscow and in the region. He is from the Cisco systems. Good morning, dear colleagues. I know my presentation is about to appear on the screen, and we will discuss the use of artificial intelligence to identifying unauthorized actions that are done with DNS. First off, I would like to show where DNS is used in our everyday life when our organizations and us are being attacked. And usually we see the result and DNS is the tool that bad actors use to commit about 80% of modern attacks. How did you decide to become a hacker? I don't know what it means to become a hacker. Is this like a guy who types quickly and doesn't sleep at night sitting in front of the computer? And that's not me. No, I'm just looking at people's behavior and seeing what makes them click on links. In several hours, Mark Hanning will present quarterly results. Do you believe this is a job? Yes. Well, I am very hardworking. I like researching. I look at people's lives, see what's dear to them. There is a lot of information that I can get from the sales departments because they're very respond very quickly because people are very trusting and they don't look at details. I do. It's all about the details. Nothing is better than me. Everything has to be looking right. This is not just spam. This is a letter, an email from a boss with his signature. It uses his language. What is malicious software? Well, all the codes have already been written before. I just know how to make sure people open an attachment. I'm always interested in seeing what happens when people start panicking. Hi, Rashid, please call back quickly. Something is wrong with my notebook. Are you on your way to work? Our systems are very slow. People are panicking. Can you please call back quickly? It's most likely a ransom software. It will take several days to restore. We can do it right now if you pay us right away. I don't know if it's going to help. Everyone needs to start working. All right, we have paid. I have the code. Mark, we have a big problem. They have penetrated our systems. Now they have everything, client-based and everything. Qualicart is in the news. Hackers have stolen millions of users' data. The stocks fell even more. Qualcomm's CEO resigned because of the biggest leak of data in modern history. All the financial information, and don't you feel bad that you stole people's data? Well, I just looked at it. I didn't decide to publish the data. Somebody decided to do that, but that's outside of my scope. Somebody paid me, and I did my job well. We all need to do our jobs well. In any event, the market will be back up, right? You've probably noticed that the young woman changed just one letter. Qualicart became Qualcart, and of course the users did not notice this, and so they opened an email from their CEO, supposedly. I think this is really the gist of most of the attacks committed today. Remember the last time Russia was accused of hacking several international organizations. This was a similar situation. And if we look at what's provided as proof, well, it wasn't tied to anyone who actually committed. We can see that the bad actors hide their identities to make sure they can't be seen.
This is an attack against US servers that was mounted from a domain which looked very similar to the one that sends out the Google password change information. The peculiar feature is that G is replaced with Q, and they look the same, especially on a small screen. If you're using your smartphone, for instance, you won't be able to notice any difference, and that results in the fact that resulted in the fact that bad actors had managed to fool the U.S. officials, thus getting access to their classified data. This is the second domain that was used to mount the attack, and in this case they did not use the Q character, rather they added a third O into the Google domain name, and that fooled most of the users because they saw the familiar word and they did not pay any attention to whether there were 2 O's or 3 O's in the domain name, and this is the real Google domain name. And the DNS traffic shows that, and the domain itself proves that it's a real one. Domain name systems can be used for creating phishing sites. They can also be used as a target, as well as a tool for mounting various types of attacks to ensure data leaks or carry out any other attacks such as DDoS attacks and so on and so forth. I will give you more details on that later on. One of the most important, one of the most interesting types of attacks is type squatting. And that requires some knowledge of psychology, human psychology. Most of you are using smartphones, so when you type in a website name with the help of your smartphone, I'm more than positive that oftentimes you make a mistake by pressing a button nearby because your fingerprint is larger than the icons on your smartphones. Therefore, you're more likely to make more mistakes when typing in the names of various domains. And when you press enter, you assume that you will go to a wrong page and that you will get a warning from your smartphone saying that there is no website like that. But bad actors do understand both the psychological and physiological aspects, and that's why they are able to create fake domains for misuse of DNS systems. These are 2 good examples when security guys created domains that could have been used by bad actors. The first case is www.bankofamerica.com, and there is no first dot after the www, right? And this is a totally different name. So usually we never even mention the first dot, which means that a poorly qualified user will type in the domain name without the first dot, and what happens is that such naive users will get to this domain registered by the security expert. In the second example, there is the first dot, but letters GF are close by on a keyboard, and it's easy to make a mistake when typing in the name of the domain on your keyboard. It has also been registered by the owner of the domain to avoid that. But this is an example when these domains were not registered. If you type in N instead of a P, and again, these letters, these characters are right next to each other on the keyboard, you will get access to a Forex website. If you try to get access from Russia, from other regions, you will get access to a totally different website. If you add a www, you will get access to a raffle website, which will say that you won a prize. And this is what bad actors use to misuse the DNS systems. The same holds true for Russia. If you make a mistake when typing in the name of the largest bank in Russia, if you type in instead of Sberbank as Sberbank, you will you will be rerouted to a casino website or to a totally fake website which has nothing to do with Sberbank. And because of that, bank loses quite a high number of potential customers. What do we do with problems like that? Actually, it's quite easy to identify domains like that, and it's not a problem to update blacklists of sorts. However, ordinary users and even security experts face larger problems because the number of such domains can be extremely high. It could be counted in tens of thousands. Let's take a look at another example. The English S is replaced with English C, and this domain really exists. It's a real one. So if we analyze what's happening with this domain, we'll see that it sends out the malware codlocks. This is an encryption software suite which is designed to encrypt the PCs of users for ransom, for extortion. This is one of the most dangerous software malware because it allows the bad actors to make money, and according to various estimates, 18 to 300 million US dollars can be made with the help of just a single piece of malware. And 140,000 US dollars is something is the overall amount that small-scale bad actors make. This software uses DNS as a tool to conceal its activity by constantly switching to various domains that are generated automatically, and they are only used once or twice in the course of an attack. Because of that, it creates a huge infrastructure. Therefore, if 1 to 100 domains are blocked, it will not yield any good results because the bad actors will switch over to other domains and other IP addresses that are assigned to these domains. This is a dynamically moving environment which can hardly be dealt with the help of traditional tools such as blacklists. If we are lucky and if we block one of the domains by chance, we won't be able to block all of them. Timba, one of the malware software suites, looks like that. Highlighted in violet are the links between domains, and the dots are the domains themselves. So even if you try to block 100 domains, it will not yield any positive results because the bad actors will just switch over to other domains. And the consequences are quite clear. They will be able to camouflage their activities for a very long time and continue stealing money from the end users. And the situation is getting aggravated. 100,000 domains are registered on a daily basis. It goes without saying that this is just the tip of the iceberg, and we're not even talking about third-level domains or domains below the third level. Take a look at this image, please. This is a malware program that penetrated a company network, and it doesn't use the .txt files to steal data and then transmit it to the outside. It uses this subdomain. The length of the subdomain is 131 characters, and this is where the stolen data is concealed. This is an anomaly. But since such domains can be generated within seconds, they could number tens of thousands. Updating blacklists will not help you any if you deal with domains like that, because ultimately the security resources will be overloaded if they are used for combating such domains. However, this length is an anomaly. Please take a look at the left-hand diagram. The distribution of domains and subdomains clearly shows that three-character domains, and I'm talking about www, is at the top of the list, and most of the domains follow a 7-character name. All the rest are anomalies. domain owners who create such domains for advertising campaigns or marketing campaigns can use that, but the longer the name of the domain, the closer attention should be paid to domains like that. Unfortunately, you won't be able to do that manually, and to this effect, you would require innovative cutting-edge tools such as AI, and that's what I'm going to focus on. Why do we need AI in the first place? Domains are changing rapidly. They appear and they disappear all the time. The life cycle could equal several minutes for a domain. Therefore, static rules that are updated once every hour or once every half an hour won't help you any in combating this threat. Therefore, we need to shift away from the traditional approaches when we try to include in the security system everything that we know. We should try and teach the system to identify things that we are not aware of, and this is the main difference between the traditional security systems and the machine learning-based or AI-based systems. We just input some data, it's a training sample, and based on this training sample, the system itself learns how to identify previously unknown data. It goes without saying that you have to train the AI-based system first, and then it will run on its own, making all the decisions on its own. It goes without saying that machine learning is not a silver bullet. I will highlight the most important weaknesses in the machine learning algorithms and the AI-based systems. However, this is the future, and without AI, we won't be able to solve the problem of ensuring DNS security. Unfortunately, the static security systems are no longer able to deal with dynamically changing and rapidly changing threats. The idea is nothing new. Sci-fi authors have mentioned that time and again in their books, and the automation, and by that we mean shifting the workload on a robot rather than a human being, has been known for ages. Hephaestus, who created Talos, a robot who circled the island of Crete 3 times per day, is a good example of using an AI or machine learning system aimed at ensuring security. Nevertheless, the technology itself, despite the fact that it became a buzzword several years ago, is nothing new. Machine learning as a definition was for the first time used in the 1940s, and then every 2 decades it gained popularity. Right now, we are at another peak of interest towards machine learning, and the reason is quite simple. Not only are there new algorithms around, now we have big data which we can analyze, and based on that we can draw relevantly good conclusions. In the past, we didn't have the required amount of data for the machine learning algorithms to be effective and efficient, and that holds true for various walks of life, including information security. On a daily basis, online, 1 trillion DNS queries are generated. Therefore, in a year, that amounts to several hundred trillions of queries, and in a couple of years, that means that we generate quite a huge database which can be used for drawing conclusions, which in their turn will be used in the future to identify currently unknown malware. The name of my presentation is a misnomer by in itself. It's a the translation from English is rather poor. AI, artificial intelligence, should be translated literally as an ability to think, similar to the way a human being does. A machine is just faster and is not affected by any outside factors, because people tend to get tired and make mistakes, and that's not the same for a machine. Therefore, artificial intelligence, like I said, is a buzzword of sorts. However, experts rarely use AI. Experts use machine learning as the main definition because it reflects to a better extent what's happening around us. Let's dive into the machine learning and the way it works when we analyze DNS infrastructure and architecture security. Let's take a look at the following sample. Domains or DNS queries should be prepared in advance, and this is a key thing because it will predefine the effectiveness of the system. You have to process the raw data, and then you input the data to a certain algorithm. You can use neural networks or non-neural networking systems that predefine the decision-making algorithms. By teaching the system once, you'll be able to feed totally new data to it for it to make its own decisions. And this is a key point here, and many people tend to ignore it. Machine learning consists of two elements. The first one is training, because you use data samples to teach your machine learning based system. And then the second element is the production stage, when the previously unknown raw data is fed into the system, and then the system, by using a predefined algorithm, makes a decision whether the domain is a malware based one or not. And the same holds true for DNS queries. Machine learning combines these two elements, but these two elements are two totally different things, because training differs considerably from production. Cloud computing and business intelligence are one and the same thing as far as machine learning is concerned for end users. But as for corporate security, these are two different elements, because the operator teaches the system, then submits it to the end user, and the end user starts operating it based on the algorithm inbuilt in the system. That doesn't mean that the system will teach its own self if new attacks if new attacks emerge. It's totally wrong to assume that a system will be able to identify brand new attacks. You will need to provide a sample to the system for it to train itself, and only after that will it be able to identify new attacks. For a business intelligence expert, it's one and the same, but for corporate users, it's slightly different. They need to understand that they have to train or retrain the system first, and only after that will it be able to block or identify new attacks. Many people tend to forget about that. Most people believe that artificial intelligence is a way to solve all the problems, and they won't need to train their systems as soon as the vendor supplies the system to them. Unfortunately, this is not really so. As for the main three components inherent in a machine learning system, they are shown here, and the same holds true for DNS malware queries. The first element are the data sets or the data samples. The second element are the parameters. In other words, what parameters are you going to track in the DNS queries or in the database to identify a malware-based DNS system. And last but not least are the algorithms. Unfortunately, we are at a starting point of developing this particular domain, because as of now, we lack a standardized data set that could be used for training AI-based systems. And what's even more important, we should have been able to use these data sets to double-check the effectiveness of the algorithms. Each and every producer uses its own database to ultimately make conclusions. companies strike a deal with internet providers. They get copies of DNS queries, and they are able to analyze the traffic on the fly or in real time. They can analyze both DNS queries and DNS responses. Given a high number of DNS queries and DNS responses, we will require some sort of automation because manually we won't be able to do that. Unfortunately, there is a motley crew of national and international vendors, and each and every one of them, depending on when they joined the process, in other words, when they started analyzing DNS queries and responses, have their own data sets. Some of them have been working on that for 10 to 12 years. Some of them have only been working on that for a year or 2 months. But based on that, the effectiveness of the system will be either high or low. Much would depend on the links between the domains, the IP addresses assigned to these domains, whether these domains were based on autonomous systems, whether they were moved around or not, who were the owners of the domains, did the owners change. This historical data is really important in the context of information security. In real life, you don't care whether the owner changed or not, but in the sphere of information security, you can carry out an investigation into a malware campaign. We can actually prescribe attributes to bad actors, and various law enforcement agencies did just that across the world. Currently, the data is not valid yet, but many people are pursuing this goal because the hindsight analysis combined with additional data can help you identify the attributes such as the nationality of the cyber criminals. You won't be able to identify whether they are governmental officials or not, but at least you can pinpoint the nationality of cyber criminals, which is also relevant. This is one of the key problems that we are currently facing, namely the lack of data sets that we can compare and compare the efficiency of various algorithms. Studying images, X-rays, and healthcare solutions are based on standard data sets. Even the NetFlow traffic analysis can be based on such data sets, which is not the case for the DNS security efforts, because, like I said, the diversity of the companies is too huge. There are some companies that have been in the market for the past 5 years, while others just joined the market. And from the end user's points of view, there is no difference amongst them. So coming up with standardized and public data sets is a must for us. And naturally, companies should be willing to share data sets with us. Otherwise, each and every vendor will try to deal with the same problems in their own ways, and it will be up to the end users to come up with a solution to the problem caused by the closed nature of the market. The next element of a DNS system is the features. Features can be allocated from either the DNS query or the DNS response, and by running these features through a certain algorithm, we can draw a conclusion whether the DNS is legitimate, whether the domain is legitimate. Actually, it's not just about the name of the domain, the registration time, and the subdomains inbuilt in it. DNS lines contain even more information. We're talking about real-time data such as the life cycle, the IP addresses resolved by the domain, the entropy data, in other words, whether the characters in the domain names are really random, the contact data of the domain owner, the geo data, is also part of it, and by that I mean in which region the domain has been registered and whether the IP address contains that data. This seemingly useless data, when combined, boils down into a serious tool that could be used in various investigations. And the task is double-fold. You can either block the domains on the fly, I mean, you can block the queries to such domains on the fly, or you can do the post-factum investigation into the use of the domain, whether the owner tried to conceal this domain from the law enforcement agencies or the special investigatory bodies, and so on and so forth. These are the three main blocks of features that can be analyzed by the machine learning systems with the help of the algorithms prescribed. The DNS infrastructure will then be secured with the help of these algorithms. What should we pay attention to? The number of IP addresses resolved by the domain. 1 to 2 addresses is quite normal, but if you have 100 or 200 or 1,000 IP addresses, it's abnormal, which means that either your resource is too popular, or it actually means that the bad actors are trying to use the fast flux technology. In other words, they jump from one domain, from one IP address to another very quickly, so that no one is able to detect domains. The IP address just lives for a minute to 2 minutes, and then the bad actor switches to a totally different one, and static signatures and blacklists do not work in that case. The number of countries where the IP addresses of the domain are located. The length of the domain name. I already told you that the average length is up to 30 characters. If it's longer, then it deserves special attention. It might be part of the advertising campaign, or it could be a feature of malware. Because if your subdomain has length of 100 characters or longer, that means that either the data leak is being concealed, or this is a DJ domain, and I will talk about that later on. The life cycle of the domain. Naturally, there is an average life cycle. If my life cycle is 3 minutes, then it's something abnormal. In other words, you have to pay close attention to the life cycle of the domain. It might be a shell domain. And, well, there are shell banks, shell companies, and the same can be applied to domains. Shell domains exist for a couple of minutes or a couple of hours, not days. Therefore, it's difficult to use traditional tools to block them. The age of the domain, or the time span. Naturally, new domains require closer attention, especially if other features are salient in them. Abnormal does not always mean malware. You cannot equate the two definitions. You have to consider the features in their entirety. The distribution of the characters in the domain name. If you create a domain for your own company, for instance, for running an advertising campaign, whether you want it or not, you will still have to use the distribution typical of the alphabet you're using. For instance, the Cyrillic alphabet for the Russian speakers, or the English alphabet for the English speakers. If the distribution of the characters in the domain name is somewhat equal, in other words, the characters to a more or less equally distributed, that's one thing. But if the distribution is not equal, that means that the domain has been created automatically, which could be a malware feature or an advertising campaign feature. It happens. Like I said, you have to consider the features in their entirety. This is the beauty of the machine learning system. A human brain is unable to analyze all the features at the same time. At best, you can analyze only 2 features, while a machine can process hundreds of various features while simultaneously identifying links amongst them. Whether, as for the last bullet, the bad actors can now automatically generate domain names based on vocabularies or glossaries. There is a malware company that automatically creates domain names out of the words used in the U.S. Constitution. From the viewpoint of entropy, these are valid domains, but they're misused and they're generated automatically. Let me give you the following example. This is the distribution of the domain name length. The vertical axis shows that the average length is up to 30 characters, and most of the domain names are within this range. Everything outside of this scope is an anomaly, and cluster algorithms could be used to group various features based on similar parameters to identify any deviations from the normal distribution of the domain name length.
Here, you can see some of the typical examples on the vertical axis, and then others, the domains in YouTube and Slack and stuff that are about outside of the range based on the number of symbols, for example. So we look at all of these, not just the length of the domain name, but also there are a number of subdomains. Another example on this is the fast flux technology, where you have one domain hiding many IP addresses. So in red you have the IP addresses, and in white are the main domains, right? And which again proves just how difficult it is to block these types of malicious companies and domains automatically, or not automatically, but by using block lists, etc. Moving on to algorithms. We already have data sets, we have features or tags. Now moving on to algorithms. Let's look at this screenshot. If you look at it carefully, you see that there are 2 or 3 domains queried every minute or so. It means that this is some sort of an automated action. Means that there is a program that does some sort of a regular queries outside, externally, right? And it does so using some sort of a randomly generated set of symbols. This is worth investigating. So if there are a few domains like these, then I can, in fact, use signatures or static rules or templates that a security company might give me, right? Kaspersky, Python, and others. There are plenty like this. We could also use statistical methods. Those are the ones that we have to write code for in advance. And then the third version, an option, is using rules. For example, routers that would have domain names recorded in them. But this database of rules would then become very large. Mathematically, it has been proven that any signature using any program using signatures at some point reach some sort of a limit, because at some point all of the signatures and the rules reach such a huge number that no machine will be capable of holding all of them, right? So you always have in the end databases and servers that use data sets that then find anomalies. So one of the weak points of machine based on artificial intelligence is that they are not 100% right or wrong. They have some sort of a in-between solution that says there is a similar anomaly, but we can't say if this is 100% malware or non-malware. This is probably something that any non-signature based system weak point. So there are many algorithms in information security. Probably about 100 algorithms of machine learning exist that are applied to various types of problems. There is no universal one for identifying abusive behavior in different types of settings. Different attacks require different algorithms. Tunneling requires one type of algorithms. DGI domain abuse requires different type of algorithms. However, all of these could be put into two categories. One category, essentially, sort of you have a teacher, right? I have a data set. I have a person who teaches the system at first, as in it tags system data and saying this domain is good, this domain is definitely malicious. And then the algorithm uses the learning that it received from a human, and this algorithm will then classify and categorize what's happening without a human present. Today, up to 75% of information security algorithms are based on a teacher setup, because any database that tracks domain activities, it uses this approach. Right? So we could say that, for example, one domain name sends out malware. This means that the domain needs to be put into some sort of a list. It doesn't mean that a domain is abusive. It might not belong to bad actors, but it has at least been hacked. So we need to block access to it until the domain owner removes malware and code from the domain pages. Then there is another set of algorithms. They're not less popular, but it's just that there is not enough math time tested yet. So these algorithms use neural networks. Essentially, those are algorithms without a teacher. The latter type of algorithms actually are believed to be more future-proof, because those can draw conclusions without a human present at the beginning. There are few of those for now, but for now they are not as numerous as the teacher-based algorithms. The teacher-based algorithms are so far used more to counter contemporary attacks. Then there are other technologies, classification and clusterization. This is mostly a terminological type of discussion. I don't want to go deep into that. Some say that classification means learning and clusterization without learning, but then there are in-between versions as well with both present. But generally, let's say that there are teacher-based algorithms and non-teacher-based. Algorithms and neural networks are the latter. Now, here are some examples. this is a joint query model. We see a joint query addressed to some set of domains. If we know that one of those domains is malicious, then we could conclude that other domains within a set time might be at least suspicious. There are some exceptions where some legitimate and non-legitimate queries happen in the same period of time. However, those are few and far between, and we can't say that this type of algorithm helps us identify abusers' infrastructure, not just one set of exchanges, but a whole structure. We have another example here. I see all the related relationships. You don't see here the very domain on top, but that's how connected queries look. You need to look at this when you do your investigations, because you have to look at in your logs at whether or not you have all of these domain names, and then think about why these domains appear in auxiliary services. Now, then if you have a peak of activity, for example, it's a DDoS attack using exploitation kits and tools, some phishing-based companies, they all have a specific traffic signature. You can compare those to what's happening in real time. So if I see, for example, that current traffic is similar to a profile that I've already seen in the past, then I can conclude that this current traffic is being sent by a phishing-based company or something similar. And here we see a query to send to a domain in .ru. It looks like an automated query, but you see you have a 0 queries, then a peak, and then again no queries. You can draw all sorts of conclusions here. Either it was a marketing campaign, or it was a malicious activity, and without additional features, additional investigation, we won't be able to see what this was. I'm going to tell you that this was actually a malicious activity. Next, monitoring predictable behavior. This is where we analyze malicious domains, right? We already know the malicious domains. And so if we see IP addresses that look similar to the ones that we've already studied before, we can conclude that these new IP addresses are also malicious. So this is another tool that we could use along with others to analyze malicious behavior. So you can see that there is not one single universal algorithm. They're used in a combination as a set. You can't use just one algorithm because that's error-prone. Here you see an example of when there are malicious domains tied to one IP address. That's because we see malicious code sent out from it, and these is a set here of other domains hosted at a specific address. So you could ask yourself, why are they all attached to the same IP address? Either this is the registrar who provides this, or because this is tied to a region known for hacker infrastructure, clusters, and that the registrars are not sort of very well behaved. Now, in speaking of communication between the DNS and corporate systems, that's another tool for identifying malicious behavior. If there is integration with internal systems that use standard protocols for transferring data. Now, if I get this type of information, then in affected domain and its communication with external malicious node, that's something that I put in my database for future investigations. This means that either information is being stolen, or there are commands that are expected from the outside, etc. So this is the type of investigation, interaction going on between internal and external worlds. Now, there are also strategic intelligence companies. There is Group IP, Kaspersky, Fireside, and others. There are several tens of these companies. They look at compromising identifiers, then we plug those into some sort of a model, and then we look at all the interactions as well as concomitant interactions. So something that happens next to me in time or geography, I see it, and I can conclude that this behavior is malicious. Moving on, while the bad actors are moving to more standardized behavior, for now they're using sort of entropy, if you will, in generating domain names, right? You know, a normal person would not come up with names like these for their companies or campaigns. And so if you see domains like these, well, they're pretty easy to identify. We could say, yes, this is a DGA domain, but this means that either this is a marketing campaign or a malicious attack. Here is an example of a domain identified as DGA, but since it's in yellow, it means that we don't know whether it's malicious or not. So if you look at and use the known DGA domains, we can then create mechanisms that can forecast these types of domains and algorithms. It's rather easy because the algorithm that creates domains, it could be deconstructed, allowing us to say what other domains might be created. It's sort of predictive analytics, i.e., domain has not yet been created, but we've already blocked it, right? This is kind of the future of information security in DNS infrastructure, because those types of predictive models are few and far between for now. For now, it's machine learning, but really it's descriptive diagnostics, or something that requires us to understand what's going on, but not what will happen in the future. Few are able to do this predictive modeling yet. Moving on. There is interaction and correlation between DNS and BGP. That's another algorithm. There is also geolocational analysis. There are some sort of clusters and centers in online, centers of malicious systems, etc. And so if there is a query coming from it or going to it, also increases the likelihood of maliciousness. This also applies to concomitant data, right? So this is spam distribution, malware distribution. And so the more malware appears from a domain, the higher the likelihood of that domain being abusive. This is not random. And if it happens over time, this means that it is a cluster. Here's an example. For example, I have an IP. It has a certain number of domain names, and the threat score is 100 out of 100, and it happens over several days, which means that these domains are definitely malicious. Because all of those domain names are distributing malware. It means that this is a whole malicious infrastructure. Another algorithm, newly created domains. In and of itself, in themselves, they are not abusive, but it's the timing and the location and the context of their emergence that's important. Here you see a number of domains related to Microsoft brand name or trademark. You've got several legitimate and not legitimate names that are exploiting this trademark. So supposedly the administrator is supposed to think that this is yet another Microsoft site for updates, for example. And so the admin is supposedly not going to look at this type of domain. This is another trick used by abusers, for example, with Facebook and others. So, is machine learning and artificial intelligence, is this a panacea? Unfortunately not. We are at the very beginning of this journey. We haven't achieved full automation yet. So far, most algorithms use algorithms, and humans are prone to mistakes. And so this teacher-based learning, it can be used by abusers. My colleague, Anton Chuvakin, Vice President of Gartner, about 20 years ago, he was talking about this in the context of risk analysis, but today it can be applied to machine learning. He said we can have data but not the model. We might have the model but not the data. We are at a stage in machine learning where we have data and machines, but we don't have enough people capable of combining those two. So the so-called data scientists, people who understand all of the various there are few people who are specialized in this. He believes there are 5 people in the world. I think the number is higher. But in any event, there are very few companies that are in machine learning. Most are just maybe going in that direction. Here you've got 2 examples of malicious companies. In one example, the company uses not the Constitution but the Declaration of Independence of the U.S. And in another example, they just create DGAs using a dictionary that consists of 1,300 words. So some others use machine learning to overcome other machine learning. Gibson was talking about it, for example, where one artificial intellect tries to win over and combat another machine intellect. So they use some sort of limitations and limits of the system. We are rule-based. Malicious actors are non-rule-based, which works to our disadvantage. So machine learning might be used to our detriment. That's a risk, and so we need to be ready for that and for the likelihood that bad actors will use machine learning against us. Also, if we use machine learning to ensure security, that machine learning can be attacked. There are a number of algorithms to attack machine learning algorithms. There is an example. There is a chatbot in Twitter, and bad users taught this chatbot to be nasty. You see very well just how it worked. This is an example of an attack on an algorithm, and so the algorithm is retaught in the process, and so the algorithm can be taught bad conclusions. However, an algorithm can be taught not to see bad things. So when you develop models, you need to make sure you create rules, and you need to feed it data in the right way to make sure the algorithm makes the right conclusions. So intellectual intelligence, it needs to be protected itself as well. It needs to have defenses on the level of the model and the infrastructure that this intellectual intelligence uses. Otherwise, it becomes an expensive toy that creates a false sense of security. Now, what else do we have? We have algorithms, data sets, features or tags. Sort of, let's say we know how to combine it to identify malicious activities in DNS infrastructure. This means that we also need good analytics, right? There are strides being made by experts. There is descriptive analytics, and this is where most machine learning algorithms reside today. Then there is diagnostic analytics, that has to do with why. Then there is forecasting analytics, and then sort of prescriptive analytics about what shall I do. This all means that we're at the beginning stages. You have the Game of Thrones series, right? I'm sure most of you heard of it at least. So there is a fan of this series that recorded all of the deaths occurring in the series, and they put that online. This is a limited set of data, but this is to show just how well algorithms work. So we could break up every series into segments, right? And we can see that towards the end of every series, we're in season 7 or 8, I think, we see that deaths occur mostly at the end. It's probably logical. Why kill them at the beginning? Let them suffer first, right? To make sure every episode is watched by more people. But here you have a proof of this idea. Here we see that deaths occur towards the end of a season. Anyway, we can use this model these data to build a model and then analyze things. We just saw histograms and diagrams, and those were descriptive analytics. Talking about when characters die off most often. We can do that based on what we see. Now, diagnostic analytics. That is, at what point shall we see an episode and at what point in the season shall we watch the series to make sure we see the most deaths, for example? Now, moving on to forecast analytics. There is very few things being done there. DGA domains are in play here. Those can be used to predict what domains might be created in the future. And then finally, prescriptive analytics. That's where, based on analysis, we give advice on what should be done.
There are exceptions. This is an example of one of the systems, but the recommendation, which is highlighted in yellow here, is so obvious that you didn't have to engage in machine learning. Scan your nodes and try to identify malicious nodes. Well, it's quite obvious, and any information security student would have been able to give out a piece of advice like that. Therefore, these algorithms and the machine learning itself as a discipline are only at a starting point of the overall journey. And that is why most of the organizations and companies are cautious about rolling out all these technologies. Despite the high promises, only 5%, actually 6% of the companies have rolled out the machine learning-based systems into production or operation. Others are still closely monitoring and watching the outcomes. In conclusion, let me share a piece of advice with you. Since machine learning in analyzing the DNS infrastructure and the domain database, as well as DNS queries and responses, is not an ideal tool, it's quite clear that we need to use a combination of the technologies to improve the security of the DNS infrastructure against accidental actions as well as malicious actions by bad actors. Thank you for your attention. Well, actually, we do have a couple of minutes for some questions. Go ahead. Good morning. My name is Alexander Evsanyan, the Internet Protection Society. Thank you for a wonderful presentation. It was quite interesting, and however, you failed on touching upon the responsibility of such companies as yours, because you were talking about the bad actors and so on and so forth, but you failed to mention the accountability. An expert from Cisco Umbrella told us about the way to identify bad actors and so on and so forth. And in his presentation, he said that Snowden Relations, WikiLeaks, and other organizations that use DNS to bypass the monitoring by the government use very similar technologies. And I guess Snowden is the major bad actor, but in Russia we beg to disagree. Who's going to take the responsibility for banning Snowden, the AI, and so on? Alexander, personally, I believe that Snowden is a traitor. He is a bad actor. That's my personal view, and I can probably justify things he did for the good of the humankind, but being an information security expert, I believe that he broke all the possible rules, including the ethical codes and so on and so forth. Unfortunately, the machine learning algorithms are still a problem, and I don't think this problem will ever be solved, because people will use these algorithms in their own ways. As for the accountability, this definition is not really applicable as far as the ethics are concerned. If a legal domain is considered to be a malicious one, it could be blocked, and someone should bear responsibility for that. Or if you block if you fail to block a malicious domain, then you should also bear the responsibility for that. But as for the moral issues and ethics, I do understand that it's a philosophical question. I'm not ready to get into a heated debate on the issues that are being discussed on Facebook. I was discussing the tools. As for the application of the tool, it's up to the operators. It goes without saying that you can use a microscope to hammer the nail downs, but you can also use this tool to identify the bad actors or block the malicious domains. It's a philosophical question, like I said, and it's up to the operators to decide how to use this tool. We only have time for one last question because we're way behind the schedule. Please be brief. I will be brief. Yuri Garbalov, I come from Ukraine. My question is as follows. Everything you have mentioned so far is great, but I'm really confused about the role of the machine learning in the global life cycle of domains. Let me explain what I mean. The positioning is based on whether it's going to be the cloak and dagger war. Is it going to be the chasing game? Everything you have mentioned should be rolled out at the stage of registering the domains. When a domain becomes a malicious one, it doesn't make any sense to apply your algorithms. I do understand that there will be some difficulties pertaining to the various policies pursued by the national governments, the registries, and the registrars. However, we have to go there. Otherwise, we will be chasing and we will be losing the cloak and dagger war. The AI, similar to the non-AI technologies, will not help us win all the battles because the bad actors will always be ahead of us. Thank you for the question. Well, my only comment is that at the level of domain registrars, it might work if the registrar is legitimate in the first place, and if a registrar wants to combat illegal domains created through the registry. In that case, we'll be able to block the registration of the malicious domains. However, if a registrar initially pursues a business model of making money on on crimes, and there are lots of registrars like that across the world, it goes without saying that it doesn't make any sense to deal with them at the stage of registering a domain. It will only take the on-the-fly analysis to block such domains with the help of the AI technology, or it should be done at the corporate level. As soon as the domain comes into appearance, these tools are the only way to identify malicious domains. If the domain was created as a malicious one, you won't be able to do anything with it at the registration stage. Well, you can predict the behavioral patterns. Let's take this discussion offline because we are way behind the schedule. Thank you for a wonderful presentation. Thank you for sharing a brief outlook of the future with us. It's a cyberpunk of sorts. Let's take a brief coffee break and let's resume at noon. Please get back here and we'll be discussing the fundamental changes in the DNS infrastructure and the Internet IP address.